So let's see whether my sound is clear or not. Enough. Checking is enough. Yeah, that much fast. Now, doesn't this chapter looks little bit like useless? I'm starting this video just like that, live that also. Because why not? Be honest. It's a fact. How can I teach you without actually stressing or telling about the main point or main thing that affects you? Like mole, atom, molecule. What is going on and why is it that? It might be like that to you. But you know one thing? Everything depends on this chapter. The charging in the battery of your phone. Like why does it charge and how does it get charged? How it discharges and charges. Like let's say if you are using some fuel, candle, some kind of oil or anything, that fuel gets used out. How you can recharge the battery? The taste of the snacks, even the air you are breathing, everything depends upon atoms and molecules. So whether you like it or not, if you master this chapter, you are going to be very much better. You have a big advantage in your 10th class and overall chemistry, even 11 and 12th. Therefore, we must pay attention to this chapter and we should value it, whether you like this chapter or not. Now onwards, you must like it. By the way, I find that the bulb I have, that's not switch on, so my light will be, hey, light is clear. Anyway, from light I remember, let's light up your brain. I will show first of all how does atoms or molecule, instead of going to the definition and this and that, let's see how does it actually look. Because in the school, teachers are very good, nice, but they can't show that every time. So let me try that and show how does it actually look in 3D. So let's try it once. If you can see, that's nice. If you can't see, I'll make you see. Can you see? Oh, yeah, you can see. So this is actually the thing. Okay, this is an atom you are seeing, and due to this atom only, you will be able to see. I will remove my thing so that you can focus only on the atom. My thing, I mean my video. Okay, so now you have to answer me in the comment which one is electron, which one is neutron, and which one is proton. Tell me in the color, and if you say it correctly, in your dream you will get chocolates. If actually you get improved in study in your life, you can have your entire chocolate factory. Anyway, so on the sides you are seeing, these are the electrons, and this red color, these are electrons, and these green are protons. So can you tell why this, how these greens are the proton, and how do I know that these green are proton? Can you say? See, usually the number of electron and number of protons are equal. Okay, let me try to zoom it. Yes. Okay. Now observe the number of green balls. Those are not balls, by the way, those are proton. And the number of red one, both are 3. Okay, so that's how you can say these are proton and electrons. Okay, now charges, which one has which charge? The electron usually has negative charge. Observe this minus sign. See here, minus sign. So it has negative charge, and the proton, the green one, has positive charge. Okay. Now if they have charge, then why won't get electric shock? Like why, if we touch anything, why don't we get electric shock? So see this one, positive charge. They cancel out each other. This is the basic concept. By the way, which molecule is that? I mean atom, not molecule. This is neutron. Okay, this atom means this one thing. First of all, this one is neutron. The color sky blue you can say, or greenish blue you can say. This one is cyan I think we call it. So this one is neutron, and this is, which atom has 3 electron or 3 proton, or atomic number is 3? That's Li, lithium. Okay, that's lithium. Now let's see some basic concepts of this chapter, and then we'll understand the whole chapter one by one. So now some important concepts of the chapter. If you have any doubt, you don't understand something, you ask me. So first of all, the main thing is, for thousands of years, the scientists have been, like humans, have wondered, if we keep cutting a piece of matter, what is the smallest particle we reach? Okay, that's a molecule, and if we break it further, we find out that it's atom. Okay, now the atoms together form a molecule. Now you would be like, sir, atom, molecule, you ride a cycle. How the cycle is made up of? Usually it has two wheels. So molecule is also like that only. But the difference between your cycle and a molecule is generally your cycle has two wheels or two supportive, so total four wheels. But the molecules can have two wheels, three wheels, four wheels, any number of wheels. Plus that if molecule is made into a cycle, so one wheel can be cycle wheel. So let's say this is a cycle wheel. One can be a tractor wheel, one could be a bulldozer wheel. Okay, what do I mean? Let's say CH4. Now this is like a bulldozer, but this is like cycle. Okay, hydrogen are small, very small, only single electron. Whereas carbons are big. Okay, and they have four outer electron, total 6 electrons. Okay, so that is what I meant by this thing. Anyway, so now the definition, you should know it. An atom is the smallest particle of the element that can take part in chemical reaction. Atoms are basic, this one we know already, basic building block. Molecules, a molecule is the smallest particle. The main thing in this is a element, particle of an element or a compound that is capable of an independent existence and shows all properties of that substance. Okay, in simple letters, a molecule is made up of two or more atoms. That's the thing. And it is also made up of two or more elements. When it is made up of two or more elements, it's called compound. Don't forget that. So if same element, then just element. Okay, element is element. But if different elements, like CH4 earlier I said, no, it's a compound, methane compound. Then it's compound. Okay, that's a big difference. We will look into that later. Now, laws of chemical combination. If you understand this law in your 10th class, not just 10th, in 9th and other classes, it will be so helpful. So we will also learn why actually they react at all, why there is a combination in chemically. That also we understand. So let's see. Law of conservation of mass, stated by Antony Lavoisier, like that only to read, na? Maybe, in 1774. So what that law tells us, it's a simple thing. You know, we have learned that thing that in matter in the universe is constant. It cannot be created, cannot be destroyed, or energy cannot be. It's same kind of thing. So mass can neither be created nor be destroyed in a chemical reaction. So that is called law of conservation of mass. Very important. If they ask, like, yes, you have to note it down. Very important. Not just important, very important. Okay. So, so in simple terms, the total mass of a reactant is always equal to the total mass of the product. I will do that in front of you only. I will do a simple reaction, means I will show. We'll do reaction also. 3D reaction we'll do actually. So simple. Let's say we burn just a carbon in air, C plus O2. So we get CO2, carbon dioxide. So one carbon here, two oxygen here. One carbon here, two oxygen here. So total number is 3. Here also total number is 3. So mass did not change. Their combination changed. Here only they are individual. Carbon is single, whereas all oxygen is 2. Here they all three combined. Okay. But did their mass change? No. So that's it. Take a screenshot. If something was confusing and just now you get it, then definitely take screenshot. Compound, I did not write D over here. Now it's better. It's looking better. Let's see how it connects to the real world. Let's take the example of baking a cake. If you weigh all the ingredients before mixing them, like not just a cake, if you are cooking something or you are making Maggie, so how much packet you take, that much Maggie only you will get. Yes, it will increase in size, but that's due to absorption of water. And then weigh the final cake. So cake also, if you take the weight, you might find the cake weighs slightly less. Why? Not because mass was destroyed, but it just got evaporated. But some mass escaped as gas, water, vapor, carbon dioxide, blah blah. If you could trap and weight those gases, the total mass would be exactly same. That's uh, the real life example of this thing, that mass cannot be created or destroyed. Now here comes the technical part, law of chemical combination. Here only I have seen many of the students, they have to beat their head on the bench. Okay, yeah, that's like sometimes very frustrating. Okay, but if you understand, okay, yes, it's funny for now, but if you understand, it will be more funny because you'll win it. So, law of constant proportion. And now, what do you mean by this? I will give an example. Let's say I did reaction of carbon plus hydrogen. Okay, so here there are H2, 2H2, 2 hydrogen. Actually, this reaction generally doesn't occur. Well, I will give simple reaction H2 plus O2. Now, what product I will get? I will get H2O. Okay, but here there is two oxygen. So I should write H2O2. Wrong. Okay, because that's not a water molecule. So water molecule have a constant proportion. What is this proportion? 2 hydrogen to 1 oxygen, 2 is to 1. This is called law of constant proportion. That's why I never do that. Like here 2 oxygen, then here also 2 oxygen. Then you would be like, sir, how would we balance it? Yes, that you will learn in 10th, but still I'll tell you, show you. Let's simply multiply this with 2 hydrogen and then make it 2. Now we got total 2 to the 4 hydrogen, here also 2 to the 4 hydrogen. Here 2 oxygen and this 2 multiplies to oxygen also. So 2 oxygen. So both sides it's equal. This is how to do it. So this law of constant proportion was stated by Joseph Prost in 1799. This law states that in a chemical substance, the elements are always present in definite proportions by mass. Now, what do you mean by that? Now, let's see if you make a human diagram. So, how you make it? You will say, sir, is it human or octopus? Because I have made 3 legs, isn't it? So, generally, we make this one. So, a human usually, unless it's an octopus, it will have 2 legs, 2 hands. That is called law of constant promotion. Proportion, not promotion. Whereas if we draw, let's say, some animal, I'm trying, I want to draw it fast. Let's say it's some animal. Okay, so it will have 3 legs, no? No, it will have 4 legs. So their proportion is fixed. How many legs will each animal will have? Like for example, some insects has now different number of legs. The birds has 2 legs usually. The birds usually have 2 legs. Okay, so if it is bird, it will be 2 legs. That's constant. If it is human, it will be 2 legs and 2 hands. Constant. If it's an animal, 4 legs and 1 tail. It will not change unless the animal did something wrong and cut its tail by mistake or somehow. So that is the meaning of law of constant proportion. Okay, so like here, water, hydrogen will be 2, oxygen will be 1. Here also they have said 2 atoms of hydrogen, that is 2 unit mass, and 1 atom of oxygen, 1 unit mass, and oxygen mass is this 16. Okay, so 2 ratio 16 is the proportion of their mass. Just divide these 2 by 2 and we'll get 1 ratio 8. Okay, same thing what I have told here, same thing they have said in the mass. Got it? If you still have any doubt, you can ask me. Now let's find out what actually is an atom. Okay, so scientists were wanted to know, they were in like how the matter is made up of, and some scientists did different kind of experiments. Each one discovered different types of atom or different information about atom. So let's see from Dalton atomic theory key postulates. Before that, let's have a look to the atom in 3D once again, so that it will get more clear to you what I am talking about. So see, this is your atom, or let's see this the general visualization. In here, what you are seeing, the orbit. I will see that one because this is big one. Yes. Okay. So these are different orbitals. Okay. And in the middle, there is nucleus. Generally in the book, the design will be something like this. The nucleus will be like a circle. Okay. And then surrounding will be the orbitals. Got it? In the starting, the scientists used to think like it's something like this without like watermelon, and there will be some electrons and other particles in the middle, like watermelon kind of structure. Okay, that was originally. So see what Dalton thought about this atom, how what he thought and what he find out. So as per Dalton, all matter is made up of very tiny particles called atom. Yes, obviously atoms. Atoms are indivisible, means you can't divide them. Particles which cannot be created or destroyed in a chemical reaction. You know, one reaction actually can create or destroy atom. Yes, it has not been given in a book. You have never heard it. I'm saying is a fact. Guess which one? It's called nuclear reaction. It's just a fun fact. That's why I told. Okay, which is dangerous. Anyway, so connects to law of conservation of mass. Atoms of oxygen no, atoms of a given element are identical in mass and chemical properties. Yes, each atom will be of an element will be equal. Like all human will be not equal. Yeah, all ants will look like same type of ant will look like same. Okay, so in that way, human will not look equal to us, but overall to the animal we will look like equal only. Like they make pollution, humans as per the animal. Human means those organisms, those destroy the nature, make pollution, causes trouble to each other unnecessary, and then yeah, all the animals would be thinking that only. Next, they would be thinking we got ruled by the human pet us or human cage us, puts in a cage, and the same human designed another smaller cage for himself called phone. Animals would be thinking that is a human. So yeah, it's a little funny kind of thing, but obviously human would think that way. Anyway, so okay, atoms of a given elements are identical in mass and chemical properties. Okay, done. Now let's focus about what else Dalton said. Atoms of different elements have different masses and chemical properties. Like different animal look different. Atoms combine in the ratio of small whole numbers to form compounds. Now you would be like, sir, what is this small whole number? You see, earlier I made this thing. This, he is talking about that. Later on, we'll get to that full practice, like how do they actually combine. We'll have question also, so that you'll get pro in this chapter. We are just going through the basics. Now let's see what is a common misconception the people get. A key part of Dalton's theory was that atoms are indivisible. In reality, as I said earlier, the nuclear reaction, it can separate it. Also, electrons get separated in like what is electricity? The flow of electron. We now know this is not true. The discovery of subatomic particles like proton, neutron, and electron proved that atoms can be further divided. Yes, keep that in mind. Also, his idea that all atoms of an element are identical is not entirely correct. Isotopes, isobar kind of things are there. Okay, we'll learn that also. So this is important part. Keep this in mind that even though Dalton said at his time, but we find out some errors were there. Now, what is atom, size, symbol, and why? Let's see some question, and after that we'll see now. So let's directly jump to a question. Here is a nice mind map of the chapter. We'll learn about that. I created this whole notes I created for you. So what is atomicity of ozone? Okay, guess what would be? Define the atomic mass unit. So atomicity of ozone is 3. That's it. Even O3 overwritten here. There, it is already given. Okay, the number of atoms in a molecule is called atomicity. Okay, now what is atomic mass unit? Guess once. So atomic mass unit also called AMU. Atomic mass unit is AMU. Yes. Something else is missing in that. Can you guess what it is missing? It's not the whole concept of atomic mass unit. One thing, AMU is correct, but something else is missing. Just a minute. Let me think. See, I only created and I forgot. It's the smallest unit equal to exactly 1/12 of the mass. Atomic mass was used by carbon, okay, as atomic mass unit. So atomic mass unit is 1/12 of the mass of carbon. We'll see that later. No, why see that later? I'm going to show this one. Only this one. Okay. Rest of the question I'll show later. So I have all those answers for you people. Here. You want these notes, na? I'll upload to my website. This website, pandesarbestclasses.com. Today or tomorrow I'll upload. You can ask in the comment also. So this one atomic mass unit is mass unit equal to exactly 1/12 of the mass of one atom of carbon 12. Okay, or just carbon you can say. That's the atomic mass unit. Now let's get back to that concept we had been doing, and then we'll see the questions also. Like the first we should understand the basics. Let's see what concepts are remaining. You must know what actually an atom is. So yeah, these are some symbols. Here is the size, 10 to the power minus 9 meter. Do you understand what do you mean by this? I'll say divide 1 meter. 1 meter is roughly like expanse of your hand, you can say. Okay, divide 1 meter by 10. Okay, that's 10 to the power minus 1. Only minus 1. Okay, now divide 1 meter by 100. Okay, that's 10 to the power minus 2. So 1 meter you have to divide into 1 below 1, 2, 1, 1, 2, 3, 4, 5, 6, 0. That many number of time you have to divide 1 meter. It will be like tinier than 1000 pieces of an ant. Don't do that. Ant might get angry, might try to revenge on you. Okay, but incredibly small it is. Now here we have some important symbols or abbreviation. For hydrogen, O for oxygen, Na, iron, or you can say iron. Other than that, for carbon, C, sodium is given already. What else is important? Chlorine is Cl, phosphorus is P, and what else we use generally? Sulfur is S, aluminium is Al, magnesium is Mg, and likewise so many are there. Now let's see atomic mass. Atomic mass is very easy. Oh, wait a minute. But are you clear with atomic number and atomic mass both? Let's find out. Okay, so here it comes about the periodic table. In periodic table, the atoms are arranged as H, then He in the end, then Li, Be, D, C, N, O, F, N, O, F, Ne. So like that it is arranged. Okay, and helium will be above it. So these are noble, they don't react. Now the first one will have one proton inside, so it has atomic number 1. Atomic number 1. Now helium will have two proton inside, so its atomic number is 2 and it never reacts. Lithium has 3, beryllium has 4, boron has 5, carbon has 6, nitrogen 7, oxygen 8, fluorine 9, neon 10, which is also noble. It doesn't react. So doesn't react. Okay, this is the atomic number, you must learn it. Okay, like I will speak for you once, you can try. HELI, BEBCNO, FNE, NAMGAL, SIPSCL, ARKCA, STTR, MN, feconicogen. That's it. I have said 30 atoms. Yes, 30 elements I have said. Now atomic mass. Generally, if you double this, it will be atomic mass. For helium, He atomic mass, atium mass generally will be 4. For lithium will be around 6. For beryllium 4. For carbon atomic mass will be 12. See, double. Okay, not always, most of the time, but not always double. Don't think it will be always double, because atomic mass is proton. Where is that atomic mass? Here. So here, atomic mass equal to proton plus neutron. Okay, so how many number of proton is there? Let's say helium has 2 proton, 2, and it has this mosquito also. It doesn't have mass. It's mass. Hey, you see, generally I don't like to kill organisms, but that infection should not affect me, na? Okay. So nitrogen has like 2 neutron, so total 4. Okay, that's a helium has 4 atomic mass. So that's it, as simple as that. Atomic mass is proton plus neutron. I'll switch on the fan because they're bothering me. But before that, let's see one nuclear, not nuclear, a chemical reaction or a simulation. How does chemical reaction occur? Just a minute, I'll find it, like I'll get ready with that. So we'll go to periodic table, or we'll see reaction first of all. Chemical reaction. It's better to see those things. How are the atoms? How do they react? And what happens in that? And by meantime, I will switch on the fan so that these little helicopters won't bother me. I think you can see it. Okay. So let's try to react them. So here you can see these things are reacting. Okay, try to guess in this what is reacting to what. Which atoms and which molecules are involved. You have to check it. Try once, guess it once. If you guess it nicely, that's great. If you don't guess it nicely, then you must study now what you're doing. Since when mosquitoes came over here? Okay. Anyway, I hope you can understand this thing, what is going on. So I switched on the fan, and here what you're observing is, see, this thing. Can you see this? This green wala, green running away. This green. Okay. So this green is chlorine, Cl2, and this one orange, yes, here it is given, is sodium, and they join together. Got it? That is what a reaction happens. Let's see one more reaction. So water reaction, yes, H plus O2. So let's see their reaction. How do they react? So over here what happened is H2 plus O2, they combined. The yellow wala is here, you can see here, this one, don't run, don't run. This yellow is hydrogen and this blue one is oxygen, and that is how we got water. Okay. Now let's see what are the remaining important concepts, because if you understand the concept, then only you will be pro in this chapter. So molecule of compounds, this one I have already said. Okay, what is a molecule? So these are all, if there are two different elements or more than two different elements, then it will be compound. So it contains, molecule of a compound contains atoms of different elements chemically joined together. How does that chemical reaction happen? That also I'll say. So ions. An ion is a charged particle formed when an atom gains or loses electron. But how? Again, I will show in, no, not 3D. This time I will make myself this thing and then I will show you. So let's see how does it happen. Let's take simply sodium, Na. Na has atomic number 11. Okay, and let's take another one, chlorine, Cl. It has atomic number 17. Okay, I will make their atoms. So sodium I will make first, 11 proton, 11 neutron. This is the nucleus. And then this is the second nucleus. Oops, not egg, nucleus I have to make, not nucleus, orbital. So let's say this is the second orbital. Let's make their electrons. So first we'll have 2 electron, 1, 2, and then outer shell will have 8 electron, 1, 2, 3, 4, 5, 6, 7, 8. Total are 10, but we need total 11. So let's take one extra, external one. Okay, it will have one extra. Now let's make for chlorine. This is for sodium. Now this is for chlorine. So Cl, chlorine. Chlorine, and this is Na, sodium. Okay, now the thing about chlorine is it will have outer shell 17 electrons. So outer shell it will have 7 extra, 1, 2, 3, 4, 5, 6 and 7, which it doesn't like. It want to have total 8, and what it will do, it will gain 1 electron from sodium. So sodium will lose the electron, sodium's electron will be gone. Okay, this electron of the sodium will be gone to chlorine, poor fellow. So let it will be gone. Yes. Okay, now this is from sodium, and since sodium got 1 less electron but 11 proton are still there, due to this extra 1 proton it will have 1 positive charge, plus 1 charge, whereas the chlorine, due to this extra electron which is having negative charge, it will have minus 1 negative charge. I'll write up down upside. So negative charge and positive charge. Now these are the ions. Okay, so this is positive ion or cation, and this is negative ion, that is anion. This is the ion concept. If you still have doubt, you can ask me. So these are the ions. Cation has positive charge and anion has negative charge. Very important, keep in mind. Writing chemical formulae. For that we need valency. Earlier we did in that one proton and one electron was shared. Only one electron was shared. So valency will be 1. Okay, at that time only for sodium or chlorine, the earlier acid. Okay, generally valency means how many electron it shares or gain. The simplest way to understand the valency is how many electron it shares or gain, as easy as that. But later on we'll understand it more detail. Now see the definition. Here's the definition. If you have any difficulty in that, you can ask me. I have created some tips for you. Write the symbol of the element side by side as I did earlier. Write their valencies below them. Crisscross the valencies, and that is how you will form their molecule. And here is the nice example. For example, Al valency is 3 and oxygen valency is 2. So let's put this 3 and let's put this 2. Al2O3. That is how it formed. Okay, so this is a simple and easy method to find how many atoms will be there in a molecule. If you still have doubt of what is going on or anything, you can ask me. Okay, but yes, till now you understood what is an atom, what is a molecule, and we have already solved some question also. So you are much better and much ahead. Now let's find out some more important concept and then we will do some question also. So here, molecular mass and mole concept. This is what eats the student's brain the most. Okay, but remember earlier I said everything, all the elements depend on their atomic number. So molecular mass, generally everything is connected to atomic number. From atomic number you get atomic mass. So molecular mass will also come from atomic mass. Very easy, just you have to combine them. For example, H2SO4. So hydrogen has 1, sulfur has 32. Similarly, oxygen has 16 mass. Okay, let's add them. But here there are 2 hydrogen, so 1 into 2. Here there is 1 sulfur, so just 32 is enough. And then oxygen has 4, so 16 into 4. How much is 16 4? Yeah, write down fast in the comment. Okay, 64. Do some basic revision. Plus 32 plus 1. Okay, so 5. 7 and 9. 97 will be the atomic mass of H2SO4. That's what sulfuric acid. Let's check it. What? Oh, this is not 1. This is 2. Okay. 98, not 97. I also made mistake. But we are human. Sometimes we can make. The thing is, why I wrote 97 and why it is 98 over here. I wrote 1 for hydrogen. Okay, but actually it's 2 times. 2 hydrogen. See here? That's why. Okay. Okay. Laughing is good, but done. Now let's carry on. So just to keep this in mind, you can take the screenshot. Okay. And just to practice this one, you will get pro into calculation of molecular mass. It's very easy. The big deal or brain eating thing is mole concept. That also I'll tell. Don't worry. It comes with Avogadro number. Here comes the mole concept. So you need to learn the Avogadro number. That's 6.022 into 10 to the power 23. Okay, Avogadro number is 6.022 into 10 to the power 23. What do you mean by this number? I will say Avogadro number like 6.022 into 10 to the power 23 is the total number of atom in that same mass. For example, I will give example, then you understand. Let's say hydrogen mass is 1. Okay, hydrogen, since poor guy, hydrogen, it has only one proton. So hydrogen mass equal to 1. So in 1 gram, how many hydrogen will come? In 1 gram mass, hydrogen will be how many? What will be the number of hydrogen? That will be 6.022 into 10 to the power 23. Now let's see how big is that number. That number is 6.022 into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 23. Okay, so if this is 23, then so that many number of hydrogen atom will be there in 1 mole, okay, or 1 gram. So that is the meaning. Now you would be like, sir, why do we need to calculate this all? You are asking nice. Okay, why we need to calculate? But when you have to buy your favorite chocolate or your favorite snack, then you don't want them not to calculate that why its taste is not as good. You tell me, without knowing which chemical is how much, how they will manufacture any product? How do they know H2SO4 has 2 hydrogen and 4 oxygen? How they will calculate? This Avogadro number helps them in calculation of where, how many atoms of what things is available. So it's actually pretty useful. Okay. So important formula. If you have given mass, okay, mass of that particular material or compound, and molar mass is given, then you can find moles. So number of particles by Avogadro number. These are the formula. We'll do some formula in practice in the question, then it will be clear. Now, these questions we already did, but here are the most repeated question in the exams, and these questions will make your concepts more clear. So the value of Avogadro's constant is, I won't say, you people have to try. Is it A, B? Don't just scroll. You have to also tell me in the comments. C or D is where? I forgot D. Anyway, guess which one. So 6.022 into 10 to the power minus 23 now. B, 6.022 into 10 to the power 23. Okay, this is correct one. What is the chemical formula of calcium chloride? Try CaCl2. Keep in mind. Okay, calcium has valency 2. In this, how we got it? Calcium has 2 valency. Okay, chlorine has 1 valency. So 2 chlorine will combine with calcium, or in simple language, Ca valency is 2 and chlorine valency is 1. So this 2 will go to chlorine. I will write here, and this 1 will go to calcium. I'll write here. So 1 and 2, 1 calcium and 2 chlorine, CaCl2. Which postulate of Dalton's atomic theory is the result of law of conservation of mass? Yes, just now I said, just a while ago or a moment ago, you can say, by the way. So try once. I will give a few seconds to you. Write down in the comment, what is this postulate, or which postulate is that? Try. Your times is going to be up, and yeah, time's up. What was the question? Which postulate? So it is the postulate that states atoms are indivisible particles which cannot be created nor be destroyed. That one. Okay. The next question. Calculate the molecular mass of nitric. Wait a minute, I'll try to make it clear. Molecular mass of nitric acid HNO3. Atomic masses are given, and yeah, let's just calculate it. You also try by yourself, then only you will get pro into that. So let's do that. H is 1, so 1 plus, then nitrogen is 14, so 14 plus oxygen is 16, we know, so 16 into 3 will be 48. Okay, and that will be the atomic mass. Now how will be this total? 63. Okay, all questions I won't do, you also have to try. What is the mass of 0.5 moles of nitrogen gas? Atomic mass is 14 unit. It will be 0.5 mole. It should be half of it, so 7 gram. Okay, wait a minute. No, something is missing. Nitrogen gas is N2, so its atomic mass 1 mole. 1 mole equal to total atomic mass into gram. So atomic mass total of the molecule will be 14 into 2. Okay, but since they said only half mole, so molar mass will be 28 gram. This will be the molar mass. But half molar mass or 0.5 will be, you can simply multiply with 0.5 and you'll get back, you know what, 14 gram. Yeah, it's just about understanding. It's not that much of a difficult thing. Now, state the law of conservation of mass and the law of constant proportion. In an experiment, 2.4 gram of magnesium was burnt in oxygen. How much? 2.4 gram magnesium. It produced 4 gram of magnesium oxide. What mass oxygen was consumed? Which law does this support? So first of all, keep in mind, magnesium was 2.4 gram. It produced 4 gram of magnesium oxide. So obviously the extra one will be oxygen. Okay, just to subtract 4.0 minus 2.4, that should be equal to 1.6 gram of oxygen. What mass of oxygen was consumed? Yes, 1.6 gram of oxygen. Which law of constant conservation of mass was there? Na? That law. Okay, I will show that, this one law. Now, what are the polyatomic ions? That's a good question. What is the polyatomic ion? And give 2 examples, write their chemical formulae. Sodium carbonate, Na2. I am giving the answer. You also have to try once. Ammonium sulfate and calcium hydroxide. Okay, one of that I will tell. Na2CO3. Okay. What is polyatomic ion? You are saying this CO3, na? It is a polyatomic ion and generally it has 2 charge. So CO3, and it will have 2 charges, 2 negative charges. Okay, so that is a polyatomic ion. A polyatomic ion, I am telling, listen the definition. So what was that? A polyatomic ion is a group of atoms with an overall charge. Okay, an example you can give: CO3 2 negative, NH4 positive, like that. Assertion and reason. This is where actual your intelligence will be checked and real practice will be over here. So are you ready? Let's be ready. Okay. Okay, because it is the most confusing. The atomic mass of sodium is 23 unit. Wait a minute. You know what? I'm going to show all the question and answer so that you can take screenshot quickly. Take it and later on you practice. Okay? And then I will discuss these assertion, reason, question and answer. Actually, let's first find out at least this one. So I'm going to do this one in front of you. Then I'll show all the answer. Assertion. The atomic mass of sodium is 23 unit. Sodium is Na11. So what? Reason: an atom of sodium is 23 times heavier than 1/12 of C12 atom. To me, it seems to be, um, is it 23 times mass is there? Let me just calculate. It has one extra neutron. So yes, it's true. Actually, it has 23 unit, and it has proton equal to P will be 11 and neutron will be 12, and that's how it will have total 23. So yes, both are correct. Okay, assertion is also correct and reason is also correct. So answer is A. Both are correct. Okay, now I'm going to show this question and then I will show you all the answers. So this is the next assertion reason question you have to try. And here are the answer. I'm showing all the answer quickly. You have to take the screenshot. Here is the first one. If you want, take the screenshot. I won't give so long time. Are you done? Now, next one. Third question. Okay. Now, I will count till 3 and you have to take the screenshot. 3 will be too fast. I'll count till 5. 1, 3, 5. Yeah. Now, we'll do next one. We have to save time also, na? So, take the screenshot of this one. If you have not taken, I'll count till 5. 5. Next question. Here is the solution. Question is over here. Solution is over here. Okay. Take the screenshot immediately. Wait a minute. Do one thing. If you missed some screenshot, go back to the video and pause the video and take the screenshot. Here is the earlier question we calculated. So full solution over here. Next one. Okay. And I'm going to show the next one. See, these calculations are very important. You have to practice it two more time. If you practice it, most of the concepts will get clear. And congratulations, you got pro in this chapter. Okay. So here is it. It's competency based question, case study, earlier one, and full solution, and that's it. The chapter is finished. Okay, if you still want to note down something, you should take screenshot and note it down. I will upload to my website. You can take it, and that's it. It's finished. Okay, if you forgot something or if you did not forget, subscribe the channel. Go to pandesarbestclasses.com. What was my channel name? pandesarbestclasses.com. Yeah. So if you forget the channel name, you can go search at bestclasses.pandesar. Okay, and you can ask your doubt at bestclasses.pandesar. Okay, classes.pandesar. And best of studies. Bharat Mata